Hey guys, today we're going to do some word problems. And I know a lot of you guys are panicking right now and saying, oh no, I can't do math word problems. I never understand them. They're too hard. That's a common complaint. But I'm here to tell you that you can do them. We can make sense of them. It just takes a little bit of time to break them down and make sense of it so that we can get to solving. So, when we're looking at word problems, there's 5 things you got to do. First thing is read. How are you going to even begin if you don't sit down, read it, and try to make sense of it? You know, don't just read it blindly and say, okay, there's this and that. Read, try to make sense of what it's asking you, what it's giving you. Second thing, you have to declare your variables. That's like saying x will be this, y will be this, blah, blah, blah. Declare your variables. Say what's going to be varying, variables, varying means changing. What's going to be changing? What do I need to declare as a variable? Then look for rates and initial values. Your rates are going to look like a slope. Will always look like a slope when we're writing linear equations, and initial values will be your y-intercept. So these are important. You can look for rates and initial values in there. After that, you can take your rates and your initial values, match them with the corresponding variables. Corresponding means they go together. Go together. So match them with your corresponding variables to write an equation. And then, does it make sense? Ask yourself, is what I just wrote meaningful? Does it have meaning in math? Can I look at this and say, okay, this makes sense. I need to multiply here. I need to add this on. Does it make sense? You have to ask that at the end. Okay, so here's our first example. What we have to do first is, of course, read. Let's make sense of what's going on here. So, a machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Write an equation that shows the total amount of income that the salesperson earns. So let's make sense of what's going on. Let's see, he's got a base salary of 40,000 and then plus a commission of 300 for every machine. He wants us to write an equation that will give us the total amount of income. So what are our variables? Let's see, we've got machines right here. So let's make that M, how about? M will be machines. Excuse my bad handwriting on this computer. And the next one I would say would be the total amount of income. So how did I pick those out? Well, those are the things that are going to be changing. I've got a base salary. That's standard. That stays. I've got a commission is 300. Does 300 change? No. What does change? Well, the amount of machines that he sells. That's a variable. Vary means it's changing. So the amount of machines is changing. And when the amount of machines he sells changes, that changes the total amount of income. So those are my two variables. Those are the two things that are changing. Okay, now I need to go through and look for any rates or initial values. So let's see, do I see any initial values? I do, because a base salary, that means I'm going to make that no matter what. Base salary is an initial value. So I have 40,000 as an initial value. Let's see, anything else? Do I see 300. And this is $300 per machine, right? This is dollars per machine sold. So $300 per machine sold. So that's a rate. This changes as we sell machines. It changes, so that's a rate. This one's staying constant, So that's my initial value. That's what I started out with. Okay, so the next thing we're going to do is put it all together. It looks like we've used all the information in here, so let's put it all together. If I want a total income, my total income, then I'll have what I start with, $40,000. That's my base salary, and then plus a commission of $300. Is it just 40,000 plus 300? No, I have $300 for every machine I sell. So I can multiply that by how many machines I sell. If I sell one machine, it's 300. If I sell two machines, it's 2 times 300, which is 600. If I sell 3 machines, it's 900. So that's why I'm multiplying here. And does this make sense? That's the final thing we got to do. Is my total income going to equal what I started with plus 300 for every machine I sell? Yes. So that does make sense. I'm good with that. All right, I'm going to go a little faster through this one. So first, let's read. Lynn is tracking the progress of her plant's growth. Today, the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. So let's declare the variables. Let's look. Height is what we're going to be looking for. We want the total height. So let's make that the variable. That's what's changing, is the height. Variable is the things that are changing. And per day, so how many days affects the height. So let's make it D equal days. Okay, let's look for rates or initial values. Let's see. Today the plant is 5 centimeters high. That's where I start. Initial is 5 centimeters. And we grow 1.5 centimeters every day. So that's changing. This is my rate. Okay, so now I can use that to write an equation. Let's see. If I start at 5 centimeters and then I'm growing, so I'm going to add, right? 1.5. I'm going to have to add 1.5, but not just 1.5, it's 1.5 times how many days it's been growing. If I grow 1 day, it's 1.5, 2 days, 3, 4, 3 days, 4.5, etc., right? So what I started out with plus how much it grows is how high it will be. Does it make sense? Yes, the total height is what I started with plus this amount for every day. Okay, let's move on to the next one. Let's read first. Mr. Thompson is on a diet. He currently weighs 260 pounds. He loses 4 pounds per month. Write an equation to represent the situation. So what's going to be changing? His weight. The weight will be changing. And for every month, those are my variables. Those are what's changing. Okay, any initial values? I start at 260 pounds. 260 is my initial. And do I see a rate? 4 pounds per month. 4 pounds per month is a rate. All right, so write an equation. If I start at 260, and then I lose 4 pounds a month, that's a little different than what we've been doing. We've been just adding this on, but this is really important right here. I lose 4 pounds a month, so I'm going to subtract 4 pounds. But not just 4 pounds, it's 4 pounds for every month. So if it's 1 month, it's 4. If it's 2 months, 2 times 4 is 8, etc., right? 260 minus 4 times the amount of months. and that'll give me my total weight. So does that make sense? My weight equals what I started with, and I'm losing, subtracting 4 pounds for every month. So yes, it does make sense. Now this is the last one. It's kind of tricky. It's not like one that you've seen before. The rest of them, we've all gotten a rate and we've gotten an initial value. Well, what's that look like? That looks like a slope, and that looks like a y-intercept, right? It always looked like y equals mx plus b. That's a line. We know that. Here's my initial value, and here's my rate. That's my rate of change. That's my slope. But this one's going to be a little different. Let's look at it and see if we can't make sense of it. So, at a school play, children's tickets cost $3 each, and adult tickets cost $7 each. The total amount of money earned from ticket sales is $2.10. Write a linear model that relates the number of children's tickets sold to the number of adult tickets sold. Okay, so we have children's tickets, adults tickets. They sum up to $2.10. So what is going to be changing? Is my final profit going to change? No, I know it's $2.10, so that's not a variable. Variables vary, they change. Children's tickets, adult tickets, those will be changing. We don't know how many children's tickets we sold. So, and let's make A adult tickets. Okay, so those are our variables. Those are what's going to be changing. Do I have any initial values? Do I have any initial values? I don't have any initial values. I have a final value. Final value is 210, right? I know that. I know something. I know when I add these up, it costs 210. That's what it says. That's not an initial value, but I have a final value. Do I have any rates? Well, yes. So I have $3 per child's ticket, right? I have $7 per adult ticket. Those are two rates. I have two rates here. So how am I going to do that? Well, let's just match it up. This is the information we have. 3 goes with child's tickets, right? So if it's $3 for every child's ticket, that must be 3 times C. Because 1 times 3 is 3, 2 be 6, 3 times 3 is 9, etc., right? If I have adult tickets, it must be the same thing. $7 times the amount of adult tickets I've sold. If this is the amount of money I make from selling child's tickets, and this is the amount of money I make selling adults tickets, then I know when I add them up, it has to equal 210. And there you go. This is a line, and you've seen that in the previous lessons. What form of a line is this? This is standard form of a line. I can change this to slope-intercept form if I want, and that's fine. The difference here is there's no independent or dependent variables. The amount of children's tickets sold does not affect the amount of adults tickets sold, and vice versa, right? It doesn't matter how many adult tickets I sold. That doesn't affect how many child's tickets I sold. But we do know this equation here. Good.